Our objectives in this lesson are the following. Construct truth tables of propositions. Determine truth values of propositions. Distinguish the proposition as tautology, contradiction, or contingency. And determine the truth value of a compound proposition. Previously in our lesson, we have discussed logical operators and their corresponding truth tables. It is imperative that you know this because we are going to use our knowledge here in our today's lesson. Constructing truth table. Let us formally define truth table. It is a table showing all resulting truth values of simple and compound propositions. In constructing truth table, you need to know how many number of rows is needed. And we have a formula for that, which is 2 to the n, where n is the number of propositions. For example, if there are two propositions, let's say P and Q, then the number of rows is 2 squared, which is equal to 4. 2 times 2 is equal to 4. If there are three propositions, let's say P, Q, and R, then the number of rows is equal to 2 cubed, or 2 times 2 times 2, which is equal to 8. Let us start constructing a truth table. I have here not P or Q. We have here two propositions, so we are going to create two columns, one for P and one for Q. Now, since we have two propositions, the number of rows that we need is 2 raised to the second power, which is equal to 4. That's why we have row 1, row 2, row 3, and row 4. Now, we are going to enumerate the possible combinations of true and false for P and Q. One is both of them are true. Another is P is true, Q is false. Another is P is false and Q is true. And last one is both of them are false. To give you a technique so you won't be confused in constructing possible combinations, for the first proposition, you write two truths and two falses. For the second proposition, it will be an alternate true, false, true, false. Next one, we have here not P. So we're going to add a column for not P. We're going to focus our eyes on column P and we just have to negate it. This is not P, negation. The negation of true is false. The negation of true again is false. The negation of false is true. And again, the negation of false is true. So we are done with not P. And then we're going to have the complete compound proposition. So we're going to add a column, not P or Q. This time, what we need is not P and Q. This is a symbol for disjunction, or let us recall our truth table for or. So in here, you will recall that the disjunction is only false when both of the propositions are false. Otherwise, it is always true. So here we have true, false. Therefore, this is true. This one, both false. So this is false. This one, both true. So this is true. This one is false, followed by true, and this is also true. This is now our answer for not P or Q. There is another way of doing the truth table. Let me show you. So in here, I have enumerated P, Q, and the whole thing, not P or Q. So in this method, I am not going to add a column for not P. I will do it directly. For not P, I am just going to negate the proposition P. So the negation of true is false. Again, true, false. The negation of false is true. This one is also true. Then I will just simply copy Q because it says here proposition Q. So I'll rewrite true, false, true, false. Then I have here the operator disjunction. So again, for disjunction, it will only become false when both of the propositions are false. So here I have one true, so this is true. Here I have both false, so this is false. Both true, so this is true. One true, so this is true. Notice that our answers in first and second method are the same. Let's have another one. This time I have not, P, and Q. So again, two propositions, two columns, and four rows. You already know how to construct the possible combinations. Two truths and two falses. Then alternating true, false, true, false. Now, since this is in a parenthesis, it is in a group, I'm going to perform this one first. So I'm going to add a column for P and Q. Now, let us recall the truth table for conjunction. So in conjunction, it is only true if both of the propositions are true. Otherwise, the conjunction is false. So let us try it here. I have here both true, so this is true. Here, both true, the conjunction is true. I only have one true, so the conjunction is false. I only have one true, so the conjunction is false. Here I have both false, so this will be false. The next column is the not P and Q. Since we already have P and Q, the last column that we solved, we just have to negate our answer in this column. So the negation of true is false. The negation of false is true. So this will be true and this will be true. Here is now our answer for not P and Q. Let's have another one. This time I have P or not P and Q. I have two propositions, P and Q. And we already have P and Q earlier as well as not P and Q. So we're just going to rewrite our answer earlier. But now I'm going to add a column for the whole thing. P or not P and Q. Let us focus our eyes on P. We need P. And our answer for not P and Q, this portion here. Our answer here is this column. Now, since this is disjunction, let us recall our truth table for disjunction. Once again, for disjunction, it only becomes false when both of the propositions are false. So we have here true, false. There is one true, so this is true. I have here both true, so this is still true. I have here one true, so this is true. Here, I have one true, so this is true. So what did you notice here? Our answers are all true. If the compound statement is always true, it is called tautology. So again, if the answer are all true, you call it tautology. Let us have another example. We have here P and Q implies not P and Q. This is getting more challenging. Still, I have two propositions here, the P and Q, and the possible truth values for them. Now, remember that you have to work at the innermost. So the innermost part of our compound proposition is this one in parentheses. So we have to determine first not P. So we're going to add a column for not P, the negation of P. And we already know that. We just have to negate proposition P. The negation of true is false, so this is also false. The negation of false is true, so this is also true. Now, we are going to add a column for Q implies not P. We're going to recall our truth table for implication. For implication, it is only false when a true hypothesis is followed by a false conclusion. Otherwise, the implication is true. So let us focus our eyes on Q and not P. So once again, it will only become false if you have true, false. Like this one, true, false, so the implication is false. Both false, the implication is true. Both true, the implication is true. If you have false, true, the implication is still true. This time, we're going to add another column for this portion from here up to here. So we're going to add a column for Q implies not P and Q. This time, we no longer need not P, so we're not going to choose this column, but we are going to choose the column Q implies not P. That is the last column that we answered. So now we have here conjunction. So let us recall the truth table for conjunction. So it is only true when both P and Q are true. Otherwise, it is false. Let me just clarify this one. We already have the answer for Q implies not P, this one, this column. And then we need Q, this column. So let us start. We have here true, false. So for true, false, the conjunction is false. We have false, true. This is also false. We have both true. So if it is both true, the conjunction is true. False, true, the conjunction is false. Last one, we're going to create another column, and this time it's for the whole thing. We have P and Q implies not P and Q. This time we don't need Q, as well as Q implies not P. We need to focus our eyes on P and our answer for this whole group here, which is the last column that we determined. So this is conjunction. So this is the same table that we are going to use. So it is only true if both propositions are true. So true, false will give us false. True, false will give us false. False, true will give us false. False, false will also give us false. So what do you notice in our final answers? This time, it is always false. If the compound statement is always false, we call it contradiction, or sometimes we call it fallacy or absurdity. Let's have another one. This time I have P or Q and not R. How many propositions do we have here? We have 1, 2, and 3. So our formula 2 to the n will be equal to 2 cubed, and that is 2 times 2 times 2, and that is equal to 8. So I'm going to create a table that has 8 rows. We have 1, 2, 3, 4, 5, 6, 7, 8. Now let me explain the columns here. This is P, this is Q, this is R, this one in parentheses, P or Q, this one is the not R, and this last column is for the whole thing, P or Q and not R. Now, what are the possible combinations for three propositions? It could be P is true, Q is true, R is also true. It could be P is true, Q is true, and R is false. It could be P is true, Q is false, and R is true. It could be P is true, Q is false, and R is false. It could be P is false, Q is true, and R is true. It could be P is false, Q is true, and R is false. It could be P is false, Q is false, and R is true. And the last possible combination is all P, Q, and R are false. I'll give you again a technique. For the first proposition, you write 4 truths and 4 falses. For the second proposition, you write 2 truths, 2 falses, 2 truths, 2 falses. And for the last proposition is an alternating true, false, true, false, true, false, true, false. So those are the possible combinations for three propositions. So let us start. Now we have P or Q. Let us focus our eyes on P and Q. Since this is disjunction, at least one must be true so that the disjunction is true. Otherwise, the answer is false. So we have here both true, so this is true. Both true, this is true. One true, this is true. One true, this is true. One true, true. One true, true. Both are false, this will be false. Both are false, so this is false. Now, we have here not are. So we are going to focus our eyes this time on are. We're just going to negate it. So the negation of true is false. This is true. This is false. True, false, true, false, and this is true. Simply negate proposition are. And for the last column, we need to focus our eyes on P or Q and the not are, the last two columns that we determined. This time, this is conjunction. So meaning both of the statements must be true so that it is true. If there is only one true, then this is false. Both true, so this is true. One true, so this is false. Both true, so this is true. One true, so this is false. Both true, so this is true. Both false, so this is false. One true, this is false. This is now our answer. And what do you notice this time? We have a combination of false and true in our final answers. If this is the case, it is now called contingency. So a compound statement that is neither a tautology nor a contradiction is called contingency. Let us do extra challenge. Let us determine if this is tautology, contradiction, or contingency. I'll use the another technique for this one. So what do I have here? I have P if and only if Q implies R and not Q. Since I have one, two, three distinct propositions, then I am going to need 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. And I have already written the possible combinations for these three propositions. Again, write first 4 truths and 4 falses. For the second proposition, write 2 truths, 2 falses, 2 truths, 2 falses. And for the third proposition, alternating true, false, true, false, true, false, true, false. If you can notice, I do not have here a parenthesis. I do not have here a grouping symbol. How would you know which one should you treat first? Remember, in my previous lesson, I have discussed the order of precedence. We are going to apply this in this example. So in order of precedence, negation comes first. So meaning we are going to perform first the negation, the not Q. So focus your eyes on Q and then we are going to negate this. So true, it will become false. True will become false. False, this is true. This is true. This is false. This is false. This is true and this will become true. After negation, conjunction comes next. So we are going to perform the conjunction. For conjunction, both propositions must be true so that it will be true. So here I only have one true, so this is false. I have both false, so this is false. Both true, so this is true. Only one true, so this is false. Only one true, so this is false. Both false is still false. Both true, so this is true. And one true, so this is false. After conjunction, we have disjunction, but we do not have disjunction here. Comes next is the implication. So we're going to perform now the implication. Q implies R and not Q. So we're going to focus our eyes on Q and our answer in this part. Again, our answer in this part is the last thing that we determine. So this column. Since this is implication, a true hypothesis followed by a false conclusion will yield to a false implication. Otherwise, it is true. So like this one, true, false, so this is false. True, false, so this is false. False, true is true. False, false is true. true, false is false. True, false is false. False, true is true. Both false is true. Now, for the last column, the biconditional. So this time, we are going to focus our eyes on P and our answer on this part. And the last thing that we solve again is the implication. So this column. For biconditional, let us recall that it is true only when both propositions are true or both propositions are false. So if you only have one true, like this one, true, false, this is false. True, false is false. We have here both true, so this is true. Both true, so this is true. Both false, so this is true. Both false, this is true. Only one true, so this is false. Only one true, so this is false. This is now our final answer. It is a combination of false and true. So this is contingency. The compound statement P if and only if Q implies R and not Q is a contingency. Let's have another activity. Prove me wrong. This time I have given English statements and we are going to determine the truth value of this compound statement. This is the same compound statement in our previous example. The first thing to do if you are given English statements is to determine the truth value of each proposition. So P is the proposition, 5 is an odd number. Is that true or false? That is true. R is the proposition, 7 is an even number. Is that true or false? That is false. Q is the proposition, 6 is an even number. Is that true or false? That is true. Now that we already know the truth values of our propositions, let us put it here below. So proposition P is true, proposition Q is true, and proposition R is false. So again, order of precedence, we have to perform first negation. So negation of Q. Our Q is true, so the negation of it is false. Next in precedence is the conjunction. So R and not Q. Since these are both false, then the conjunction is also false. It only becomes true if both are true. Otherwise, the conjunction is false. Next in the order of the precedence is the implication. So we are going to have Q and our recent answer. Now for implication, if it is true followed by false, the answer is false. And last one, the biconditional. So this time we're going to have P and our latest answer. For biconditional, if one is true and the other one is false, then it is false. So our final answer is false. So meaning the truth value of the compound statement P if and only if Q implies R and not Q is false. Let us recall our truth table earlier. Can you find out if there is really true, false, false, false in our truth table? Yes, we do have, and it is on the second row. For the summary, here are the things that we discussed in this lesson. Take time to read this. Now, it is time to check your understanding. Pause this video for more time. Let us answer. So we have here Q and not P or Q. I have two propositions, P and Q, so I need 4 rows. 1, 2, 3, 4. I have already written the possible combinations for P and Q. Let me supply the third column. That would be the innermost one, and that is P or Q. The next column would be not P or Q. And the last column is the whole thing, Q and not P or Q. So for P or Q, let us focus our eyes on P and Q. If it is or, then you only need one true so that it will be true. These are both true, so this is true. I have one true, so this is true. I have one true, so this is true. I have both false, so this is false. Next column is the negation of P or Q. So the negation of this column. The negation of true is false. Again, this is false, and the negation of false is true. The last column, we have Q and not P or Q. Let us focus our eyes on Q and our answer on not P or Q, the last column that we determined. If it is and, then both propositions must be true so that it will be true. Otherwise, it is false. I only have one true, so this is false. Both are false, so this is false. I have only one true, so this is false. Only one true, so this is false. Notice our answer are all false. Therefore, we call this a contradiction. So the compound statement Q and not P or Q is a contradiction. Gets? Our next lesson is logical equivalence and conditional propositions.